Hello and welcome to the Emerging Tech Horizons podcast. I'm Arun Serafin, Executive Director of NDIA's Emerging Technologies Institute. Today on the podcast, we're going to talk about hypersonics, particularly hypersonic aircraft, and the state of DoD's activities to try to develop and deploy these very advanced and capable systems. We're also going to talk about how the private capital world is showing some interest in investing in this area. For those unfamiliar with the field, hypersonics refers to vehicles and weapons and aircraft that can travel at speeds of Mach 5, 5 times the speed of sound or more. The game-changing capability demonstrated by these Mach 5 plus systems requires pushing the boundaries of engineering, material science, propulsion technologies, and by making breakthroughs in things like aerothermal dynamics and advanced manufacturing, computational modeling. All of these things are necessary to make any progress, let alone rapid progress, in this kind of field. And then when you're done, the mission sets could be theoretically very broad. Things like high-speed strike, ISR, intelligence, surveillance, and reconnaissance, transport, access to space. As a result, the Department of Defense has made significant investments in hypersonic programs with multiple organizations pushing out money to try to develop primarily hypersonic weapons and less so in the hypersonic aircraft side. So to help us sort through all of this, my guest is Zach Shore with the Hermeus Corporation.
Yeah, thank you for having me.
So Zach, tell me a little bit about your background, your position, and how you got to Hermeus.
Yeah, so my background going kind of all the way back to college, was a history major. Not an engineer by any way, shape, or form. Joined the Marine Corps out of college, did multiple tours in Iraq and Afghanistan as a SIGINT officer, actually. Got out of that, grad school, GI Bill, thank you everybody for paying your taxes. And then found myself sort of in the private sector trying to figure out what I wanted to do. This would have been around 2011, no, excuse me, not even 2011, 2014. And ended up at Deloitte Consulting for a while, which was a sort of a standard practice for junior military officers coming out of the Marine Corps, in particular, banking or consulting. And long story short, ended up in aerospace and defense private equity consulting. And that sort of is what put me back into the A&D world. From there into defense tech with Anduril, and now at Hermeus as the chief revenue officer.
And so it's sort of a can't hold a job kind of story there.
Yeah, ADHD on steroids.
So tell us about the transitions between these things and what you've carried from step to step.
Yeah, absolutely. So I think there's a little bit of a piece here of the challenge, at least at that time, of transitioning out of the service, right? Especially 3 combat deployments and a lot of mission, a lot of purpose, and then coming back into the civilian world and trying to figure out, where do I fit? So certainly that was a part of it. I thought I didn't want to work in defense anymore. I think this is a common story you'll actually hear with a lot of veterans. And then you find, wait, I really do. This is my community. It's part of my DNA. And so, I was at Deloitte consulting the commercial sort of space, working on autonomous vehicles as an example. And while that was an interesting problem, it just didn't grab my attention. It didn't hold my focus. And so I sort of asked myself this rhetorical question of, if I were reading the newspaper, what articles would I naturally want to read? And the answer was international relations, national security, things like that. And so I started kind of saying, okay, how do I start moving the shift of the focus back to that topically? And that was a sort of an easy enough bridge for me from consulting into aerospace and defense, private equity focus. And then from there, I did that for a couple of years. I learned an absolute ton. I learned about how the department, moves and creates money, about, the difference between appropriation and authorization, about the J books, about P1s, about R1s, and then looking at businesses, IP protection. So really got a good chance to look at the defense business, which is very unique, and came to the conclusion I wanted to be in a business. Now, at that time, defense tech really isn't what we know of it today. So this would have been 2018. And so I left the job in the private equity world and was in the Valley. And that was the first time I heard the name Anduril. And then I just happened to be on a call with somebody else in just a general diligence for my career who was joining Anduril. And the next thing you know, 2019, I'm at Anduril just saying, hey, this sounds really interesting. A great team, Palantir background, good founders, good funders, and we'll see where it goes. And obviously, I think everybody listening is aware of Anduril now. And so I was very lucky to be in the kind of the right place, right time. But I didn't know where I was going. I just knew the direction was wrong and figured, hey, if I just put myself on the correct highway, if you will, I could find some exits that really aligned with the work I was interested in.
So now you've ended up at Hermeus, which is a new player in the defense hypersonic sector, but you're making some noise now in the aircraft space because of the work you're doing on both future manned and unmanned systems, work you're doing with the Air Force and DIU and others. Can you tell us a little bit about the company?
Yeah, so the company was founded in 2018 by 4 founders, all technical background, and they're based in Atlanta. That's where our factory is. And the premise of the business, sort of in its origin, was really, it still is, but very much more so early on, a dual use kind of commercial and DoD supporting technologies. What it sort of morphed into was a little bit more of, instead of parallelizing those, you actually have to serialize them. You have to sort of think of the defense market as the first market you can use to validate your technology, to find a co-investment partner, somebody who will take the risk alongside you and your investors. And if you're successful, then you can springboard into a commercial market. And the other piece was from the founders, when they were looking at this, they all had, new space background in particular, some hypersonic background, SpaceX, new Blue Origin, NASA, was the whole world when it came to hypersonics was all missile focused. And frankly, today it largely remains that way. And they had a thesis, which I think was correct. Well, everybody's going left. We're going to make a bet and go right. I think, this would also kind of fit into the Peter Thiel 0 to 1 of don't compete, right? Create the market. And so that was the sort of origin the origin process, if you will, for this business. And we've been on that journey now for almost 6 years.
You pointed out that there are hypersonics programs out there. They're mostly weapons programs or mostly missile programs. And there's some big name companies working on these things, and the Air Force is funding and DARPA's funding and MDA's funding this kind of stuff. So get us up to speed. What's the state of play these days in hypersonic aircraft?
Yeah, there really isn't much. It's at an unclassified level, it's very thin. So I would argue the work we're doing with DIU on the Hypersonic Aircraft Rapid Prototyping Program, HARP, which has been reported in the news. There's some work at DARPA. There is a little bit of work in AFRL, and that's pretty much it when it comes to aircraft. There's some things happening in the private market space, but with very, very limited partnership, even more limited than ours. And so what you see is, I think the president's budget for FY25 was roughly $6.9 billion in hypersonics, almost every penny of that going into missile programs.
Right, which is maybe necessary to get the missile programs where they want to go, but it's not helping out with the with the aircraft side of it. So in this space, you mentioned DARPA. They just recently announced a bomber program, a far future DARPA-style bomber program, right? Next generation responsive strike. I guess there's some MDA work as well. So I suppose it means industry players are now attracted. So who are some of your competitors? Yeah,
so I think there's some of the usual suspects you'd suspect. Nobody's talking about it openly. Lockheed Martin, right? We also have Top Gun. So SR-72. I know Northrop has some activities they're supporting around the propulsion systems. I'd be remiss to think that Boeing isn't participating in this. But I think there's also a piece here that's an interesting discussion, which is the way the business models work is those companies are not going to do a whole lot unless the government cuts an R&D check for them to do it, versus the way a company like Hermeus works or a venture-backed company is the complete inversion. You're going to get ahead of the R&D capital flow because you're going to try and prototype and stimulate the market. And so our competitors have a business model constraint that we don't have. Now, we have capital constraints that they don't have. And so this is how you see these two markets work.
And in the aircraft space, we've been thinking about hypersonic aircraft for a long, long time, right back to supersonic aircraft back in the SR-71 days and things like that. When was the last actual test flight?
For hypersonic? Oh, gosh.
Is it X-51?
Yeah, I think it would be X-51.
So that's in the early 2010s.
Yeah.
And that's a few minutes of flight.
A few minutes of flight, rocket-based propulsion. Reusable versus like aircraft even has, you can tease out words there. I think the holy grail has been the turbine-based combined cycle engine, right? Be it a ramjet or a scramjet, where you can use multiple propulsion stages to allow you to go 0 to Mach 5 to 0 and sustain flight for more than 30 seconds.
So just to break that down, right? Yeah. To get up to that higher speed, the Mach 5 speed, you usually need a couple of different phases to get you
That's
there.
Correct.
And basically speaking, two approaches, right? An air-breathing, old-school turbine engine style approach to get you going, get you up to speed, and then you take over with the hypersonic flight. And the other is a rocket-based approach, right?
Yep.
And that's basically what's going on the missile side as well. So what makes aircraft so harder?
Yeah. I think there's a couple things. One, on the turbine side, you don't have a turbine off the shelf today that can get you to that ramjet, scramjet light point, which is roughly around Mach 3 for a ramjet, which is where we're focused. And so you have a technical gap if you really want to have true reusability, especially with a turbine. So our approach has been using Pratt & Whitney's F100, which is a workhorse of an engine. Pratt & Whitney is a great partner. Raytheon's invested in us, so it's very well aligned. And between our work with a pre-cooler, which is just a device that sits ahead of the turbine engine and essentially injects water or mist in front of the engine to create more thrust with no real modification of the engine, you can get that propulsion system operating up to Mach 3. At that point, you can then light the ramjet and transition off of the turbine engine to the ramjet. There is some contention around whether water is operationally feasible. I have a very strong opinion it is. Water is a part of the logistics chain as it exists today. This is not new. I mean, that's always the question, logistics chain, which is correct, but I would argue this is not that trade. And even some of the payload trades of if you're carrying water, you can't carry munitions or fuel, but that's no different than any other trade you have for payloads today, be it radars or weapons or anything else. And then the other version of that would be a high Mach turbine engine, which does not exist. So, a turbine engine that would allow you to fly up to Mach 3 without water. That would be multiple billions of dollars to prototype, to build, and then even potentially to run through certification. You see this as an example with Boom and the supersonic side for commercial, where they're going to have to build and certify an entirely new engine. Rolls-Royce was at one point a partner, and when they looked at the cost of just the supersonic engine, they backed out of that project. And so, in a world where you're not capital constrained, you're not time constrained, sure, we could go build these bespoke systems, but we live on Earth in a DoD with a DoD that is constrained by capital, by politics, by other limitations, its own bureaucracy. And so, whether or not that approach is feasible remains to be seen.
And let's say you do this, what's the speeds you're thinking about? So
we're focused really at like Mach 5, a little bit above. And
what can you do with that?
Yeah, you can do quite a lot. At an unclassified level, you're very survivable. And for my operational analysis friends, there's a little bit of tension here of how survivable. I would argue we're splitting hairs a little bit, because an unmanned vehicle that could hit those speeds would be inexpensive enough and would be unmanned that even if you lost the vehicle to enemy fire, you would probably win the cost exchange on that engagement. So, and if there's nobody on board, there's no CSAR requirement to go search and rescue and remove them. What are we talking about? So you have inside force, intelligence, surveillance, reconnaissance. You have strike. You have reconstitution of comm nodes. You could have very fast logistics. I think one of the great missions would be kind of the Vietnam era Wild Weasel mission, where you just kind of scream through an area and see what lights up to do targeting. And it gets after a lot of parts that the department's wanting to work on. Highly responsive fires, long-range precision fires have been a focus for a long time for good reason. PLEO, which would be, enduring ISR, is a huge focus, although not a panacea. And so is this another tool in the tool chain, in the toolbox, that can unlock capability for a relative cost that's feasible? At the same time, where we're focused in that Mach 5 speed is not going too much above it. And this is really, I think, important. And you talked about DARPA Next RS, which we're very familiar with. When you go above the low Mach 5, you start to have some challenges in the materials, which then gets you into a cost question and a production question. If you're in the low Mach 5s, you can have a hot vehicle. So you can have a predominantly Inconel titanium vehicle, which allows you to mass produce. When you start getting up above Mach 5.5 and into the Mach 6 plus, even if you had the propulsion system, which jumps to scramjets now, your vehicle would require materials that are not mass producible. And now your cost is going to run away and your production capability is going to rapidly decline. And so there is a focus of, hey, what is the sweet spot for cost capability in the technical world? And it really looks like it's about Mach 5 that unlocks that.
But this is not technically a miracle that you're trying to pull off. I mean, crudely speaking, right? We have reusable hypersonic planes, space planes, right? The space shuttle,
correct,
was an example of this, right? And there are always discussions of, well, there's this classified space plane and that classified space plane. So are there any open hypersonic reusable space planes right now?
There are none.
There are none.
There are none. And I would agree that this is not a science project. This is an engineering challenge, and this is certainly
controlling your costs.
Yes, absolutely. Timing your capital. This is a doable do.
All right, so it's a nice overview of the space thing. One last thing to touch. Are we in first place, or some of our competitor nations?
I would not. It's hard to say what. If we're in first place, it's by a hair. It's hard to prove that. I wouldn't be surprised if we're not in first place. I will say, if nothing else, we do know that the Chinese are able to test at a pace that is orders of magnitude greater than ours, and that includes both in wind tunnels, which has a huge challenge for the United States, and something we're building our own engine test facility, not because we want to, but because there's no way you can get into the national facilities right now. Even if they had capacity, they're too expensive. So on that side, they definitely have more capacity. But then they're also just flying their things far more, which frankly, I'll take this opportunity. This is a plug to get the FAA and frankly the Air Force to have an actual risk-forward posture. Right now, actually, the physics that limit us are paper physics, and that is not where you want to lose.
So more on the regulatory
exactly.
side, right? Which then maybe potentially attracts more capital into
100%, yes.
Okay, so I mean, I think you've been hinting at this. Anything else you want to? Your company's approach now to try to break through all that? What's making it different? What's making it kind of work?
Yeah, I mean, thankfully, DIU has been a real lifeboat for us. We would not exist were it not for two factors right now on the DoD side. One is the Defense Innovation Unit as a partner, and the other is Congress. Congress wants this to exist and has directly provided capital into the DIU lines to continue to support us, and has continued to be highly engaged on both sides of the aisle and both sides of the building. That is not sustainable, right? The services need to start engaging in a manner that is sort of matching.
DIU doesn't do final development. It doesn't procure. It doesn't
prototypes,
sustain.
Right. And DIU only just got their big budget last year. A large part of that budget was taken by the Replicator Initiative, and so they didn't. You can make an argument that they didn't even have their full budget to go after this last year. Holding fast what'll happen in budgets in 25 and beyond. That has been our partner, right? The vestigial structures, and I use that term very intentionally, of the S&T community and how they work on these problems are dangerous, if not outright hostile and high risk for us to work with. They are not necessarily interested in partnering, and that is where traditionally capital flows from the department to problems like this.
Right. But on the other hand, right, the laboratory community, the test community has been helpful and supportive in a lot of emerging technologies, including hypersonic missiles, including things like helping SpaceX with space launch, helping Moderna with launching vaccines, right? So the point of that enterprise is to actually help American businesses develop things that are useful for national security and economics. And I would say you're right? They need to reposture themselves so that they can be more supportive of disruption, of speed, moving forward.
Yeah. Yep. No, no notes.
So one of the things that caught my eye is that you made a recent announcement about your quarter horse aircraft, and it says you built this aircraft clean sheet in like 204 days or something like that.
Correct.
So how is that possible, given what we just talked about?
Yeah, great question. So we actually just had our State of the Company for Hermeus down in Atlanta last night, and we'll be posting that video. We do it every year online, and we talk about this specifically. The reality is America used to do this in the 50s and 60s.
We had lots of X-planes, right?
Lots of X-planes, and there's a great chart that we show in the all hands video that we'll post on YouTube for Hermeus that really looks at how much prototyping we used to do before Kelly Johnson retired. Frankly, that is actually the inflection point, and it disappeared from aviation. But it is now 100% in the process and the truth in space. Elon has brought this back for rockets. And if you were just to look at the 2019 to 2025 timeline for Starship and how much iteration occurred and what they were able to accomplish, that is what we used to do in aviation. And so what we have done is start taking in that talent and that approach. So we're bringing that back. It kind of goes to your comment earlier that this is not so risky technically. It's really about matching capital and timelines and juggling all these pieces, be it financial engineering or engineering to make the business work. And so we have taken a lot of that talent from SpaceX. We have taken lessons learned from some just classic programs and applied them to the way we prototype aircraft. And so, yeah, we're really proud of Quarter Horse Mark 1, 204 days. Look, the elephant in the room is we haven't flown it. The vehicle's been ready to fly since December 7th. It was our first vehicle. So a little bit, it's like 204 days to design, build, test, into test, and then 15 months to complete integrated testing. And, we would have gone into flight, but between the FAA and some Air Force challenges, we're sort of sitting on paperwork.
So just to put the grumpy hat on for a second here, that speed is good. But, in the defense world, we kind of like to measure twice and cut once.
Sure.
Because people like you used to wear a uniform. We don't want to put you at undue risk,
Yep.
right? And I guess you're not saying you want to be technically unsure of yourself,
Correct.
right? So talk about the systems engineering
Yeah.
rigor. Talk about that.
Yeah.
You can go faster, but still do the right thing.
So I think it's about faster iteration, right? So the first vehicle is not trying to solve every problem. As an example, the first vehicle that we built, Mark 1, was a GE J85 engine, low thrust engine, relatively speaking, more thrust than the CCA vehicles. But this is an F5 trainer sized aircraft and no retractable landing gear. The principles of this vehicle were start getting your avionics understood, the outer mold line for a high speed vehicle, right? If you're building an aircraft that's going to be high speed, high altitude, it's going to have pretty swept wings. And so its takeoff speed is going to be high, right? You're not going to have large wings with large surface area. So, hey, can we build and take off and land remotely a high speed outer mold line aircraft and start there, right? This vehicle has no utility for a warfighter whatsoever. It is completely a learning aircraft. At the same time, some of the things we learned was, okay, from our avionics standpoint, we want to parallelize the avionics integration. We don't want to serialize it. We serialized it and we saw some runaway in timeline for the integrated test. So now we've got an entire avionics bay at our facility in Atlanta where we are actively managing our avionics and the hydraulics and all the systems now before the Mark II vehicle is even built. So we're able to parallelize these things and roll learnings in sooner. So instead of trying to do all the learnings in parallel, and if say it's really expensive, my left hand is doing something and my right hand's perfect, but my left hand is high risk and we crash the plane, I just lost everything.
Right.
And so for us, saying, okay, I can shrink the problem, focus on it, learn a lot, then expand the problem over and over again. So now as we get into our first supersonic aircraft, which we're building today in the factory, all the lessons learned from the first aircraft, even besides flight, just in terms of ground testing and integration, our redundancies on comms, have all been run through the ringer at least once. And so by the time you get to your last aircraft, you've done 4 or 5 aircraft programs, kind of Russian nesting dolls, if you will, before you get to that complete vehicle. And it's kind of counterintuitive. You're building more aircraft, you think you go slower. No, building more aircraft, you actually go faster.
Right. Yeah, and we recently did some work on prototyping where the other piece to this is that if there are no experimental aircraft, if there are no prototyping programs, engineers don't get to work on these kinds of issues.
That's a great point.
And then you announce to them, okay, we're going to do the Ultra Generation Bomber program. Everybody go work on it. And they say, this is the first complex program I've ever worked on.
I'm so glad you brought this up. Yes. And so you'll have aircraft engineers who have worked one aircraft program their whole life. And maybe they've worked it, start to finish. And so one of the things we found was that you need to create the talent base. And so our VP of engineering, who's a former SpaceX senior engineer, talked a lot about this early on of we have to create crucibles to build our team. And so by also having these very defined sprints on these aircraft programs, we can build that muscle in the business because you cannot go out and find the SpaceX engineer for aircraft. That person doesn't exist. If Hermeus is successful, what you'll hopefully hear is, where'd you get your engineering talent for, insert company working on aircraft? They came from Hermeus. That's what success looks like, because right now you hear that a lot and it's SpaceX, and that's great, but that is rocketry. It is not apples to apples, and so we are having to kind of Frankenstein this together.
The other plug I want to put in for is, you're a VC-backed company, you're moving real fast, you're wearing a hoodie, but government science helps, right? I'm assuming every engineer and scientist at the company went to school somewhere.
Yes.
And that school was funded by federally funded basic research and university research. You're living off of decades-old advances in propulsion and in computation and in material science. And so, we want the world to go faster. We love the DARPA and DIU programs. We can't forget the government has a role to create all of this platform that you guys can build on top.
It's a great, a good example of this is in our approach for Mark II, our high supersonic vehicle. One of the reasons we're so confident in keeping it an engineering problem is we're Frankensteining a lot of engineering from the past. The inlet, it's a NASA Spike inlet. You just pull that. I don't need to reinvent that. There's tons of data on it. Swept wings from the Mirage program, right? Delta wings from the Mirage program, F-16 landing gear, F-100 power plant. As much as we can to not reinvent and decelerate the program, that is how we're working. So we are absolutely standing on the shoulders of those who came before us.
The other piece of this, which is fascinating to me, is that you are a VC-backed company. And that is already distinguishes you from most defense contractors, but more and more are getting VC back. But the piece of it that is unique is that you're not a software company, right? You're absolutely a hardware company.
Absolutely.
So I guess, did you trick them? How did you get
Yeah.
the private capital community to invest
It's a great question.
in something that's so hardware intensive?
Yeah, so I did not participate in the early raises, so credit to the founding team. I think it's a couple things. I think it's a combination of vision. We have some very, very strong, historically powerful, engaged venture capitalists on the cap table. Vinod Khosla being the original anchor investor is a legend in his own right in Silicon Valley, and somebody who's willing to take the risk and look really far out. Founders funds on the table, InQtel supportive, Canaan Partners. There's a long, Sam Altman, a long list of folks. But I think one of the things that comes down to is, if you're hardware investing, and this is my thesis on this, I'm not an investor, and you don't have the billionaire or even hundreds of millionaire founder, so you don't have Palmer, you don't have Elon even in his early days, you really have to believe in not only the vision, but the team and the go-to-market strategy. So the vision being kind of what you said before of like, this is not undoable. We flew supersonic commercial aircraft with the Concorde. The United States was leading in high-speed aircraft before I see it as we became obsessed with low observable systems, and really all prototyping efforts and all aviation funding really just took that hard right turn into low observability and speed, kind of got put on the back burner, no pun intended. And then the go-to-market strategy. So the go-to-market strategy for us, as I said before, started out as this sort of very parallel thing. And then as we we're talking to the venture capitalists and really refining our own go-to-market, it became clear that you really need to kind of step up in the market spaces. And you can't do that without the Department of Defense. And there's a whole bunch of technologies and problems that we can solve that are adding value both to our company and to the department. So national security issues, while also unlocking more private capital and more IP. And so I think for the VCs, they could see a path. They're like, okay, I understand how hypersonics solves a problem. I don't need to know what programs are there. It's so obvious how something like this, if it existed, would add value.
So that's interesting, right? Because we usually hear I don't see the market issue. Can't DoD signal a market?
Yes.
There's no market. I see no number in the FY28 column of the budget.
This is you get that early on when the investments are low, right? So there's not a ton of skin in the game. We're now at a point where the DoD does need to start signaling the market, right? You don't get that forever. Now, the challenge here also is, the kind of Peter Thiel model of create the market, don't compete in the market, right? And so I think some of the best investors in the world are those who are willing to take the risk to be market makers and not market chasers. And so you do have a little bit of an impedance mismatch of yes, we need to fly and do these things to give the department confidence, but without naming names, one of the challenges I get sometimes in the department with regards to working with us is this sort of analogy of once you've done it, we'll work with you.
That's right.
And I'm kind of well, then I don't need you.
It's the chicken and egg.
Exactly.
Yeah.
I use the analogy of we want to talk about going to the moon, and they go, yeah, well, once you land on the moon, we'll talk about going to the moon with you. And my response is, well, once I'm on the moon, I'm not going with you. I'm already there.
Right.
And so we can get the investors up to a certain point off of vision, off of confidence in the technical roadmap, that we can start this flywheel. But at some point, the department does have to engage at a level of scale that allows us to continue. The amount of capital that exists to match to this and the sort of 3-to-1 standard is massive, right? For every dollar the DoD throws in, roughly, you can expect $3 of venture. If the Department for Hypersonic Aircraft or even high Mach systems does not start to create some stability and pathway, the capital will dry up. But we had enough competence and technical wherewithal and sort of vision matching with our early investors that we were able to secure at the beginning.
So let's talk about the government role in helping companies like you, especially in the hardware space, get to where they want to go, right? We touched on keep funding basic science, creating the next generation of scientists and engineers. You endorse that.
Absolutely.
You've gotten some funding through, as I understand it, DIU and the SBIR program. Tell us about the SBIR funding.
Yeah, the SBIR funding is very limited. So, the utility of the SBIR funding is not the funds. For a company like Hermeus, it's a hardware company. It's a drop in a bucket. But the utility in terms of getting on contract with a customer, so you can have DD-254s for clearances, so you can do data exchange, so that you can established contracting.
It gets you in the family.
It gets you in the family, and it has major applicability later if you're successful for contracting terms. So it is a long-term kind of investment for us as well.
Because that SBI award might turn into a sole source,
That's
larger
exactly right.
award in the future.
That's exactly right. I don't think it, for Hypersonics, I am a little bit skeptical to find the contracting officer who'd be willing to do it off of a SBIR, but like legally speaking, they have absolute
deeply
ability.
Familiar with this.
Yeah.
It is legally allowed to go
Yes.
from SBIR to Joint Strike Fighter.
That's right.
If you wanted to.
If they wanted to. Honestly, you never know. I mean, this is a new DoD. That's kind of where they are projecting they want to see more of. So it would be good to have it in your bucket just in case.
Okay, and then the government can play a role on the buying side. We talk
Sure.
about the market, so eventually you want them to be a procurer.
Mm-hmm.
What about the role of, do you have the ability to do the testing you need to do? Do you have the
Yeah.
materials characterization? What's the role of the ranges and the
Oh,
labs?
the ranges are hugely important to us. As a result of the fact that wind tunnels are so scarce, frankly, it's become cheaper to fly in a lot of instances than it is to even go into a wind tunnel. Programs
That's amazing.
programs like MACH-TB are going to be really important to not just Hermeus, but to others looking to get into the hypersonic space. So the ranges, I think, are not talked about enough, and the airworthiness that goes along with that and creating that flexibility. I mean, Stratolaunch has started to build a little bit of a roadmap for some of their activities, but it's still too hard. It's still too long to hit the cadence that we want back to the China competition. The labs, I think, are a tricky one. I think the labs, I struggle even with my words here because, frankly, a lot of times they're a competitor to us. And that is a problem. And we want to see them as a partner, and not in that way. And they have a lot of expertise. They have a lot of data that I think will be very useful.
A lot of intimacy with the operational users.
Yeah, exactly. And I think bringing the new entrants, Hermeuses and the others of the world together with that community would be very powerful. I don't have a great answer on the how because I haven't seen it. I didn't really see it at Anduril. I haven't seen it yet at Hermeus. We're hopeful. We don't have work with AFRL as an example, which is kind of strange. You would sort of expect that we would, but we are partnered with them in some ways with the DIU work. And so, I do think that this is where even on some of the S&T work to de-risk some of the technical pieces here, like long duration thermal management is arguably the single biggest challenge for a reusable vehicle, especially if you want to get away from exotic fluids and materials to keep the vehicle cool. Because you do, back to the supply chain, right? If we're operating these vehicles in the South China Sea or in other forward locations, the more you can simplify the supply chain and the logistics, the more realistic it is you can employ that capability, especially within an ACE concept. If you have all sorts of very high-end little widgets and materials, it makes it more and more challenging to deploy. That is an area where I think there's a huge role for the S&T community to partner with companies like Hermeus and specifically unlocking technology.
They're sitting on their own intellectual property. They're sitting on great equipment and people.
Mm-hmm.
And their job, I think, is to support the development of these kinds of systems so that Air Force, whoever, can make use of them.
Yeah.
Okay, so now the other hat the government can wear is an acquisition policy, being a better customer, being a better regulator hat.
Yeah.
You have a wish list for that?
Oh boy, how long do we have? Yeah, I have a lot of wishes. I mean, I think it really comes down to market signaling is the easiest one. You hear things like innovation theater, right? Pick a winner, all these terms. They all come back to the idea of we need to understand how you can signal. So some of the quiet things out loud. For starters, DoD is not a market. It is not a capital like traditional market. It's not if I have a great idea, capital will flow to that idea equivalent to the amount of value I create. Our values are constrained by the budget, by inflation, by other active programs. So these are a lot of times zero-sum decisions. If I'm getting $1 for myself, I'm either taking $1 from you, or we're all fighting for that new dollar being dropped in by a budget increase. And so how you signal to the marketplace, specifically the new entrants, is really important because unlike the primes, which have a business model that waits for a direct injection of capital to prototype something, the new entrants are putting capital to work ahead of time, and they get to a point where they're like, all right, I'm not going to keep this investment up if you're not going to create an outcome. So either say yes or say no. Saying no is also like a useful data point. I think what's really important here is an example that NASA had with the NASA COTS contract early on with SpaceX that literally created the space launch market. And the thing that was very viable about that approach was it was milestone-based payments with an outcome, a market sort of seeded at the end, and down select. So if you were a venture capitalist or even an individual picking a team to like take a job at SpaceX or another company, you could do some analysis on, hey, okay, so we're well funded. I believe we can hit that milestone. We'll get some more payment. We'll continue. And I see that bag of gold at the end, that if we win this race, I built the prototype and I get contract.
And those authorities to do that milestone-based approach, also not new, legal for both NASA, most federal agencies, including DoD. We've talked about this kind of thing in the past a lot. NASA COTS is an example, but it kind of resembles using prizes and procurement prizes. It kind of resembles using blocks or something like that, right? Or cycles.
Yep.
These are all things that can be done, that we just tend not to do them. One pushback on that, though, is that we're also yelling at the department to keep competition going. And it's hard to drag someone through milestones without having enough money. You never have enough money to drag everyone through all these milestones.
Oh yeah, absolutely.
So is there a way to maintain competition while dragging certain players through these milestones?
Yeah, I think it's all a numbers game, right? Like how much. I don't think the expectation is necessarily that the milestones offset all the cost. Everybody doesn't make it through, so you do have like a Christmas tree. So honestly, it is a numbers question. So I don't think anybody expects to take no risk. It's just a level of certainty that if I perform, there is something at the end. Or not, and then I can pivot my capital in another direction to pursue another opportunity.
So if you had advice for other small businesses that were in this hardware space and had a desire to go into defense, and how do I approach the private capital community and convince them that this is real and that they should potentially spend some money on a defense hardware company?
Yeah.
What are the couple of things you would tell them?
Oh boy. Well, there's a little bit of the pessimism of like, buckle up. This is don't do this. It's the Jensen Huang. What would you do over again to start NVIDIA? I wouldn't start NVIDIA. Right. So I do think there's some of that truth, but I also think that people have to understand that you have to be working on a problem that is so obvious that even if there's no market, because right now there's not a market and this is not a market, that it is. You can tell a very succinct story of why.
It's sort of a common sense.
It's a common sense thing,
answer to a common sense problem.
Right. That if this existed, it's the invert. Why would the department not buy this? Right. And it has to be, from a hardware perspective, really has to have, I think, that level of clarity and simplicity, especially because your investors are not going to be very defense savvy. And so you have to make it very obvious for them. I think one of the things that helped for us was that our investors could very cleanly, even as non-defense focused investors, answer that question for themselves with a level of confidence that could allow them to write a check.
So, NDIA's got a bunch of activities, including through the Emerging Technologies Institute, including at our August conference, including our small business division, trying to create these places to have these kinds of discussions to help these companies position themselves in this new world of, you've got a DoD customer and an end user, you got potential commercial users, you got potential commercial private funders. What's the best way to talk about defense as an interesting place to invest? How do companies find you if they want to partner with you? What's the best? Are you the best front door?
I'm probably one of the best front doors. So ZACH, Zach at Hermeus.com. Send me a note. Our website as well. We're pretty well engaged with most people. We're out there pretty heavily at this point, but you never know who catches your eye, and it's an all hands on deck sort of scenario to make this problem no longer a problem.
And over the next course of the year, what should we be expecting?
Yeah, so hopefully first flight here of the Mark 1 aircraft soon. If the FAA can just sign one piece of paper, that would be great. And then our supersonic aircraft later this year as well. I think this is going to be a huge year for Hermeus in flight. Flying 2 aircraft designs from scratch in a single calendar year will be really exciting.
It's great.
Yeah.
Zach Shore is the Chief Revenue Officer at the Hermeus Corporation. Thanks for that discussion.
Thank you so much.
And thanks everyone for joining us again at Emerging Tech Horizons. Please visit the ETI website and the NDI website to sign up for all our various events and register for our webinars, our educational offerings, including our Tech 101 series. Don't forget to join our mailing list. It's the best way to stay up to date. If you enjoyed this podcast, don't forget to like our episodes and subscribe to our channel to stay up to date with all our latest content. We're on YouTube and anywhere you get your podcasts. A special thank you to Melanie Yu and Daniel Park for producing this podcast. Thanks again for joining Emerging Tech Horizons.